Hi, here we have another question from Iran Mathematical Olympiad round number 1, year 1998. This question was probably one of the simplest questions from that competition. So we have to find the number of solutions for this equation. N factorial plus 3 is equal to 3 power n minus 1, and n is an element of natural number. First round of Iranian Mathematical Olympiad usually consists of multiple choice questions. You get plus 3 points if you answer correct and minus 1 point if you answer wrong. Therefore, you have to answer it very accurately. So these are the options 1, 2, 3, 4, and infinite. Maybe spend 5 to 10 minutes, try to figure out the solution, then come back and see the answer. All right, let's see. So this is our equation. Obviously, in this type of exercises, we have to evaluate the answers by substituting small numbers into the equation and check whether we can find a pattern or whether we can hit the small solutions or not. And then we have to figure out what to do for the general equation. Okay, so we try with the first element, we put 1. So 1 factorial plus 3, this is 4, and obviously the other side is 1, so this is not correct. If you put n equal to 2, 2 factorial plus 3 is 5, the other side, the right side is 3, so this is also not correct. We put n equal to 3, 3 factorial plus 3 is 9, this other side is also 9, so n equal to 3 is one of the solution, and then we put n equal to 4, 4 factorial plus 3, this is 27, the other side is also 27, so this is also correct. N equal to 4 is also another solution. And then if you put 5, 5 factorial plus 3, this is 123, this one is 81, so this is obviously not a solution. Now we have to see what can we say for this equation when n is equal or larger than 6. You already noticed that for n equal to 5, the left side of the equation is larger than the right side. So maybe for all n larger than 6, we can show that the left side is larger than the right side, and therefore there will be no solution for n equal or larger than 6. Let's see how to show this. We can use actually induction, and we are going to prove that this left side is indeed larger than the right side for n equal or larger than 6. So for induction, first we have to show that the assumption is correct when we evaluate it at the start point. So a start point is 6. So 6 factorial plus 3, this is 700 something, which is certainly larger than 3 power 5, which is 200 something. So this first assumption is correct. And then we assume that the equation is valid. So n factorial plus 3 is larger than 3 power n minus 1. And we have to show that this equation is also valid for n plus 1. So n plus 1 factorial plus 3 should be larger than 3 power n plus 1 minus 1. And that is very simple to show. So n plus 1 factorial plus 3, this is certainly larger than n plus 1 factorial. And this itself is larger than 3 multiply n factorial because n itself is larger than 6. So this will be larger than this. And based on the assumption, n factorial is larger than 3 power n minus 1. So we can put this one here. 3 multiply that. 1 power will go to here. So this is equal to 3 power n plus 1 minus 1. So we actually showed that if we have this assumption, we can prove that it is true also for n plus 1. Therefore, by induction, we have proven that this equation is always correct. And if this is larger than that, it means for n equal or larger than 6, this equation doesn't have any solution. So this is one way to prove that we have only 2 solutions for this equation. We can also show this by another method. So for example, let's say we have this equation, n is equal or larger than 6. What we can do is that we can calculate left and right side modulo 9. So for example, if we calculate n factorial plus 3 modulo 9, because n is equal or larger than 6, so n factorial certainly has 3 in it, and certainly it has 6 in it. So 3 multiplies 6, this one, modulo 9 becomes 0. So n factorial modulo 9 for any n equal or larger than 6 is 0. And then we have 3 here, so all expression modulo 9 will be 3. And for this case, because this is n equal or larger than 6, so 3 power 5 or 3 power a number that is larger than 5, so certainly this one, modulo 9 becomes 0. But we can notice that the left side of equation modulo 9 is 3, the right side of equation modulo 9 is 0. So this obviously cannot happen. Therefore, we can conclude that n factorial plus 3 cannot be equal to 3 power n minus 1 if n is equal or larger than 6. Therefore, the final solution for this question is option B. Two solutions we have, n equal 3 and n equal 4. Let's see what we have learned. Try substituting the first few values, for example, n equal 1, 2, 3, into the equation and calculate the results. Then look for a pattern in the answers. You see that after we put n equal to 5, the left side was larger than the right side, and then we could understand that maybe for any n larger than 6, we could prove this hypothesis. Another point is determine if one side of the equation is larger than the other side, or one side exceeds a certain number, which then you can use it to show what will be the final solution. And another point is compute both sides of the equation modulo a certain number and extract additional information based on this calculation. All right, so that is the end of the video. See you next time. Bye.